Let me walk you through our LP1 solution using LoRaWAN communication. We are working in Agritech, and this is the things that we learned so far. Development choice in 2018. When we started with LoRaWAN development with our products, we decided to use the RN2483 and RN2903 modules from Microchip. There are good things and bad things regarding this. So the good things is that quick firmware integration with AT commands, they are pre-certified, and we already used Microchip MCUs before. The bad thing regarding this is that we are bound to their firmware releases. We need to do some workarounds in our firmware in order to mitigate the issues from the RN models, and we don't have a full control of what is happening inside the RN model firmware. The selection in 2018 made sense for us due to the quick development, but if we would start the development now, we would probably select a smaller, newer chip which would support all the LoRaWAN frequencies. The LoRaWAN versus mobile network. So the LoRaWAN positive things are it requires less power to operate. Our bill of material is cheaper connectivity for the end client, option to complete pre-configuration of the devices. This is when we use the TTN and when we deploy the stations to the clients with the TTN network. Monitor locations spread across the field versus a single point of measurement gives better results from the field, and the farmer has a better overview of what is happening on the field. Long range with standardized protocol, there is no need anymore for us to make an own radio solution for the sensors. Our experience, easy deployment with the TTN, a bit more effort is needed when we do with other providers. Have a good internet connection between the gateway and the LoRaWAN server. If you have a bad internet connection, you will see packet loss. Don't offer gateway as a part of the package solution. If you are 2 hours away from driving to the gateway, don't offer it because you will need to do the maintenance, and if something fails, then the data is not there. Good range equals line of sight. So if you don't have a good line of sight, you cannot not expect to have like 10, 20 kilometers line between the gateway and the station. If you have a good line of sight, you also have deployments that are working on 60-kilometer distance. In case of issues, check complete setup before diving into LoRaWAN settings. It's often that the issue is the power on the gateway or the connectivity, the internet connectivity on the gateway, and that the issue is not on the end node. The hard part that we learned so far. Our clients, they don't really care about the connectivity. They just want to get the data to the platform and to get some knowledge from the data. The connectivity needs to be as cheap as possible and needs to work. The payload size limitation, we did a bit of a mistake here. We offered our clients to connect multiple different sensors to the main board. Multiple sensors mean that the size of the payload can vary and it can grow very quickly over 250 bytes. Different providers, different settings. With the TTN, it's easy. When you get with the other providers, you need to know exactly which settings they are using, because expecting from the client to set up these settings on the station, it's pain. Airtime restrictions, possible gaps in delivered data. We decided to go for the 15-minute transfer interval by default because we want to make sure that at least 2 or 3 data points in the selected hour are delivered to the server. Client expectations are always higher than what it can be delivered. This is true for every product. And what we need to do is we need to take the client by hand and walk the process with them from A to Z. And this is especially when they want to deploy their own LoRaWAN network. So that's more or less all from my side. I hope that you will enjoy the TTN conference and have fun. Thank you.